Thank you. So, very mindful at the end of what has probably been 2 really intensive days. So I've tried to pull off, I want to give you some substance, but hopefully we can have some fun along the way as well. We'll see how the fun bit goes. I've got a very peculiar idea of what's fun. This will become apparent as we progress. My colleagues are chuckling. I have 2 bits of AI content in this presentation, which will become apparent as we go. So they're very obvious, the bits of AI content. The rest is my own work, for good or ill. And this really picks up on the point that was made by the last speaker. There is a real need in information and records management and in digital archiving to improve our productivity if we are to deal with the challenges that we have at scale with information management. And from an archival perspective, crucially, how do we work out what information needs to be permanently kept? How do we sensitivity review it? And how do we get it into the loving hands of a digital archive? So we have this problem of scale, and it is a problem of scale that we need to not just improve our productivity by 50% over the next 10 years, we need to improve our productivity exponentially. And this is a big challenge for us all. And of course, we're all here exactly because we think that AI tools can help us in doing that. And we do have a new toolbox. Now, this is an AI generated toolbox. And what I love about it is if you peer carefully, some of these tools are completely useless. Like, what on earth are you supposed to do with a hammer that's got 2 handles? Or a pliers with only 1 handle, right? So we've got this new toolbox, and some of the tools are deeply powerfully useful, and some of them are like, what were you thinking with that? And yet we need to work our way through this toolbox and try and make some sense of it. I love that the AI has generated a toolbox with useful and useless tools. It really does speak to that lack of lived experience. You don't need to use a hammer for long to know that you don't want 2 handles on it. And this is the thing, and I'm by no means the only person to observe this. The AI tools that we've got, and in particular, large language models, they are so weird. And we're in desperate need of help and tools, but we have this really weird new set of tools and capabilities that somehow we need to make sense of. And it's worth stopping to think about what's at the bottom of the weirdness. Some of it is spelt out beautifully in this book, The AI Mirror by Shannon Valor. I've read an awful lot of books about AI in the last 3 years. Shannon's book is brilliant, because it's quite short. It's a quick read, so that's always a good start. She has this lovely metaphor, which I think has a brilliant intuition for what you have when you're engaging with something like a large language model. But AI is not in reality, part of reality, representing reality, dealing with reality. It's like a mirror. It's a reflection, but it's got that hollowness. You can tap it and go, no, it's just a reflection. And she develops the metaphor of the AI mirror in a really powerful way, particularly reflecting on how through using AI tools we can reclaim our humanity rather than like sweep away the human beings and replace us all by the machines. Shannon was previously in her career the AI ethicist at Google, which it transpires is an impossible job. I loved her book so much, I persuaded her to talk to me. And I said, have you got any advice? And her main advice was don't get an AI ethicist and expect them to solve all of your ethical problems. Mm-hmm. What you need to do is all of you learn and think about the ethical use of AI. Don't make this one person's problem or one team's problem. Something you need to learn and do collectively. So it's a mirror. I think that still understates how different AI is. I can see James looking very puzzled by this slide. I'm going to explain it. Right. So this is my reckoning. Right. So the black arrows, right, like human beings. So we have brains with neurons, 85 billion neurons, 2 trillion connections between those neurons. We developed the capacity to do arithmetic, right? So symbolic representation of numbers 10,000 years ago. The brain function that's doing that evolved for object recognition, right? We do not have a thing in we don't have like the equivalent of the von Neumann architecture, right? We don't have an arithmetic and logic unit. Right? And most animals can't do maths. Most animals can like recognize numbers up to 4 and can do that's lots more. So loads of creatures can do that. So we have developed the ability to do arithmetic only quite recently. And basically humans aren't digital. Right? We're fundamentally not digital. Whereas our AI friends are built on computers, or computers do is literally add. So they start with arithmetic. And then on top of arithmetic, you end up with artificial neurons, a lot of data, and you arrive at something that we call some form of wider intelligence. Point being that the type of intelligence that you get from biological neurons into human beings who can think and communicate using symbolic reasoning, including arithmetic, into intelligence is fundamentally different, far more than we intuit from intelligence that arrives through massive computation. And we shouldn't expect something that works like this work like us. I think I'm really driving home the point at how different, how other, how fundamentally different the type of intelligence we have available to us through AI is from the type of intelligence that we are. And I think it is underplayed how fundamentally different the types of intelligence are. Why we experience AIs as if they were human when we're chatting away to the chatbot or developing relationships with the chatbot is because of our innate ability to anthropomorphize, because we've evolved something called the theory of mind. We've evolved an intelligence that allows us to operate in a complex world full of other intelligences. And our ability to anthropomorphize is misleading us in terms of how we think about and use and deploy AI. But whilst it is a different intelligence, it is a breakthrough technology, every bit as much as a breakthrough technology as James Watt's steam engine was in its time, that led to a profusion, another mad AI image of a whole raft of different types of technology. And this again is part of the world that we're in. We're seeing fundamental developments in the ability to be able to compute large models and a raft of different applications. So with all of that, like wind in our sails, you'd think we'd be able to get somewhere. But there is a puzzle because we're now quite a ways on in this AI revolution. And it's making a big difference in some areas, but it's not making a big difference everywhere yet. So how come? Why aren't we seeing universally massive change enabled by AI? What can we learn about those areas that are advancing most quickly from areas like ours, where we don't yet have an AI solution to appraisal, selection, and sensitivity review, right? We're working on trying to get how do we get there, but we don't yet have that capability available to us as much as we would all love to have it. Now, we can learn a bit from the past, and this is an article from the revolution before the last revolution, right? So we're in the AI revolution. When I left university, I was very excited about the internet revolution. And I kept joining companies that went bust in the late 90s. When I was at school, it was the microprocessor revolution. And in the 80s, Robert Solow writes an article for the New York Times that becomes dubbed the Solow paradox. And it's basically reflecting that you could see the computer age everywhere, computers everywhere in 1987, but in the productivity statistics. So it took time for the productivity gains of new technology to materialize. And this is well known and understood. There's a brilliant book from 2012 by William J. Baumol on the cost disease, which basically is a reflection on why computers have been getting cheaper, but other things like education and healthcare have been getting more expensive. And it's to do with the uneven distribution of productivity gains. Some things have the capacity to be more productive more quickly than other things. Things involving computer hardware, we've heard about Moore's law. You can have real advances in productivity. Things involving lots of human effort, it's much harder to get big productivity gains. And there's a variety of explanations for the slowness. And the point for clocking this is to stop and think about, where do we focus and prioritize our efforts in trying to advance the use of AI in the areas that we're concerned about, in records management and archiving? False hopes, there's definitely a lot of that about. Mismeasurement. If you don't have good measurements for your productivity, it's hard to see productivity growth. I don't know how well we know how productive we are at core information management tasks. So we're going to struggle to measure what differences our new tools are going to make. The distribution of new technologies may be uneven. And then we come to where I think the real issues are for us, which is about the lag for implementation and restructuring. It takes time not just to develop new technologies, but for new technologies to be embedded in workflows and ways of working, for human beings to make sense of how to deploy and use new technologies. And there's this lovely quote, never mistake a clear view for a short distance. I think we're right to have a clear view that AI is the force, is the technology that is going to help us deal with these information management challenges long term. But we shouldn't be imagining that we're going to click a switch and find that it's all done tomorrow or next year. This is the work of a decade. I can well imagine we're going to be spending the next 10 years like incrementally making progress as we start to crack these problems. And we've been here before, and we can expect quite a lot of decision makers just keeping up with the Joneses. And I don't think that's a particularly bad thing either. I don't think we should worry about it. So we have new AI tools, and some of them are just kind of, yeah. I don't know how many of you live and work with Copilot. I live and work with Copilot every day. It's all right. It's not fundamentally changed my way of working. It really annoys me when I want someone to do something and think about something properly if they've just gone to Copilot and sent me what Copilot's told it. It's also really obvious. Like, don't just tell me what, I can go to Copilot myself. It's all right. It's not fundamentally changing our world. By comparison, I don't know who of you have tried Claude Code. It's extraordinary. In the popular press, you saw this kind of, it's been talked about as the November moment or the December moment. So the release of Claude Code at the back end of 2025. Lots of people, a bit like me, you get the Christmas break, you've got a couple of weeks. I'm going to try some stuff. And then suddenly, it's like you've, what was it that happened to the Incredible Hulk? You sort of like injected by some kind of, like, I now have superpowers. This tool is amazing. And it's really interesting to compare and control. Like, why is it that Claude Code is so transformative? Some of it is about some very particular affordances in software engineering. Some of it is about how well, not just that computers can produce code, but how well, because of compilers and interpreters, because of test-driven development, because like that you can contain and exploit the capability of the model. And unfortunately, a lot of our work, we're a long way from seeing our Claude Code for information management. Yeah. So the adoption of these new tools is going to be a time-consuming thing. And there's some fascinating work that's been done by the Behavioural Insights team that I would strongly encourage you to read. This is one of their diagrams that's looking at the ingredients that you need to move from no adoption of AI through to shallow adoption and deep adoption, and how the barriers shift as you progress from no adoption to shallow adoption to deep adoption. And this is very much about not just what people know, but how they feel about this new technology and how they feel about using it at work. And there's a lovely quote, because this is, I think, where we need to be centering ourselves and our focus in using AI in information management, records management, and archiving, which is to develop norms of use so that AI augments and ultimately enhances human judgment and capabilities and relationships. So this is not about replacing people, but augmenting And that's what knowledge and information managers need most, I think. It's to be augmented by the equivalent of the incredible Hulk moment that you get with Claude Code. If you have some time, I would highly recommend having a read of the Behavioural Insights team's publication, AI and Human Behaviour, Augment, Adopt, Align, Adapt. I think it's a very thoughtful and well thought through piece of work. So for us in archives, we have a multiplicity of areas of focus where we need productivity gains and improvements. AI for appraisal and selection, sensitivity review to aid transfer, in preservation risk planning. Oh, where's my slides gone? In areas that we find complex and difficult, like access decision making, applying freedom of information exemptions, understanding copyright, and in supporting people to work with our collections, producing content summaries, linking named entities, and providing more search tools. So we have quite a wide range of areas of focus. And necessarily, some of these problems are going to give way more easily than others. We're going to make more progress here than we're making there. I think the trick for us is going to be working out how we can take developments in one area and use it to help us bootstrap progress in another. So one of the things that we're most excited about, I'm most excited about in the last year, 18 months, is approach that originally was developed by Anthropic of basically creating a kind of standardized API layer so that you can take a large language model chatbot and plug it into a particular source or set of sources of information. And this is called the Model Context Protocol. We've been exploring how this works with some of our information resources. And what's interesting is that you can see a step change in the performance of a chatbot when you can direct it at some predefined information resources. We happen to have the government's legislation database. So it's a fairly obvious thing that's got it's got an open API. To plug a chatbot directly into that database, and you end up with a much better tool than a general chatbot if you have got questions about the statute book. In fact, it's pretty phenomenal. And because we know the data, we're able to construct the tooling and the sequence of the tasks that the AI does in a way that makes sense with the information resource that we know really well. And consequently, the results that you get back are much better. We're not the only people to have the idea of, well, this is quite a fun technology. Where you can see an API, you can put this MCP server on top. So we haven't made an MCP server for the National Archives catalogue and discovery. And we do have an API. And in this case, I found my way to MCP bundles, and lo and behold, someone has indeed built an MCP server on top of our discovery API that they can plug into a chatbot. We have not evaluated this. My hunch is this will perform significantly better for archival research questions if you plug it into Claude Sonnet than using Claude Sonnet without being plugged in directly to our data. So this is a powerful pattern. We're not the only archive who's doing this, although there's not many that are in the business of standing up MCP servers at the moment. This is a MCP server from the Swedish National Archives that they stood up at the back end of last year for much the same reason. Now, I have a hunch one of the strategies for improving AI performance is working out which kinds of knowledge asset we want to connect with and use to improve the AI's ability to be able to help us across those different contexts of use. And you can well imagine those knowledge assets, those information assets being quite different that you want to connect with or use when you're doing appraisal and selection from when you're doing preservation risk planning. You can also start to imagine what some of those assets might be that you would want to connect to and exploit and use in those different contexts. This is another MCP server against some of our collections that we have not made. People have been making these things like Topsy the last few months. So this is an MCP server plugging into the National Archives database of court judgments through the Fine Case Law Service. So this feels like a really good strategy for making a bit of progress. But it does prompt some questions. Now, I should say, you guess who these two characters are?
Aristotle.
Plato. Yeah. So there is a bit of this where you can see we're having this kind of Platonist, Aristotelian dilemma. The Platonist, what you need is the abstract model, and you're sort of working your way up to the abstract model, and the Platonists are grounding, building out from the data. And my hunch is that we're going to need to be both Platonic and Aristotelian in our approach to deploying these technologies. We're both going to need to build abstract models that we lack, and we're going to need to build things up, ground out from the data that we hold. And MCP servers are one route at the moment for getting some of that knowledge into the hands of powerful, generalized large language models. This isn't the only thing that we need to do. In deploying AI, our own experience has been that we've had to think about tasks quite differently. So there's this piece of what is it that you're doing, and how do you decompose the tasks into a set of tasks where you have a given task that the AI may be able to do well, but you're really clear about what it's not going to be able to do well and where you need human beings. And this process of task decomposition and task reimagining is going to be really fundamental if we're to successfully deploy AI. And this is hard work. There's also something about needing more and better data. And I'm so sure of this in the context of using AI for knowledge and information management. We definitely need to provide the AI systems with better data, including better conceptual data, the Platonic view, and better bottom-up data, the Aristotelian view. For example, data about the functions of government and data about previously selected records. Both types of data are going to be useful. We don't have all the data that we would like to be able to provide these AI systems. The good news is that we can use AI systems to help us create and curate better data for AI. And we can certainly use AI to help us bootstrap some of the more sophisticated data resources that we're going to need. And this relationship of data for AI and using AI for making data and playing this round, I think is going to be one of the key bootstrapping strategies if we're to make progress. And then we need to work out what is working and what isn't. And evaluation is hard. Our own experience is when we narrow our field of focus to something that we can evaluate because we understand it well enough, we can do reasonably well, but we're not in the position of and Anthropic, where we can do wide-scale evaluation. To give one example of something we have been able to evaluate using large language models, we've been able to develop a process for identifying powers and duties in legislation that fall to bits of government, which is quite a complicated thing to do because of how organisations are defined and how the statute book works. But we were able to evaluate it, and the LLMs were able to vastly surpass the capabilities of natural language processing technology and indeed what human beings could have done. There is no way we could have computed, we could have worked out manually 1.9 million powers and duties. This data is going to be phenomenally useful, I think, when we come to as a resource for information management. If you know there's a duty, there's probably some records not far off for that duty being carried out, or at least you'd hope so. So, last slide. In tackling all of this, building our muscles for task decomposition, creating better data, learning how to evaluate, crucially, test and learn. It's a long journey, but we're well on the way. It's important we all keep working together.
Great.